Model equations with angle pairs. This is the third and final video for today's lesson. So let's see how these three videos will come together. In the first video, we just wrote model equations using what was called the angle addition postulate, part plus part equals whole. But then, in the second video, we recognized angle pairs, like complementary angles or linear pairs. So in this video, we'll bring those two ideas together to finally write and solve model equations for any of the angle pairs that we've learned about. Let's recall what we need to do with angle pairs. First, we need to recognize angle pairs in a variety of situations and then recall characteristics of each pair. That was what was covered in our previous video, the second video of 3. But in this video, the focus of this video will be to apply those characteristics to write a model equation. Then we'll solve that equation and evaluate the reasonableness of your solution. This is very similar to what we did in our first video on just angle addition postulate, but now we need to apply that to our angle pairs. We'll start by applying model equations to angle pairs. Let's remember the angle addition postulate. It's that part plus part equals a whole. When we write a model equation for this set of angles, we write that 30 plus 40 equals 70. So let's translate that to an algebraic example using an actual angle pair. This is the angle addition postulate with, for example, complementary angles. These are angles that add up to 90 degrees. And you see that green box there, that's evidence that we have complementary angles and thus 90 degrees. So let's take that part plus part equals whole again, except now instead of just numbers for our degree angles, we're just going to substitute in the full algebraic expressions. So we now have a full algebraic equation to model this angle pair of complementary angles. We have two main categories of model equations. The first we talked about in the previous slide, where we have the angle addition postulate, part plus part equals whole. This comes up in complementary angles, or when two angles add to 90 degrees. But we also have supplementary angles. In this case, we have a linear pair because these angles are adjacent and form a line, and these two angles add to 180 degrees. You'll notice that that green 180 does not actually show up in our picture. That's because we need to recognize that these angles form a line, and we know that lines inherently add to 180 degrees. And we need to recognize and translate that into our equation because we won't see the number in our problem. We also have congruent angles. That's when an angle is equal to another angle, not that two parts add to a whole. This comes up with vertical angles, and in this case, we just set those two angles equal to each other. They're algebraic expressions. Each are on their own side of an equal sign in an equation. This also comes up with angle bisector, evidenced by those congruent arc markings that are on the angles. And in this case, we also set one angle equal to the other angle. That is a model equation for this angle bisector. Let's see a full example where we solve for x in a novel situation, such as in a rectangle. Here we have these two angles, 2x and 3x plus 60, and they form some kind of angle pair, and we want to solve for x. So let's start by first recognizing which angle pair we're dealing with here. And we'll notice that since these angles form a line, these angles form a linear pair. So we'll recall the characteristics of a linear pair now. In a linear pair, these angles add to 180 degrees because they form a line. So we'll use that to apply and write a model equation. And that's that 2x plus 3x plus 60 equals 180 degrees. That 180 comes from the fact that we have a line. We'll then solve this equation. We'll notice that we have like terms with the 2x and 3x. They'll come together to make 5x. Then we'll bring down the plus 60 equals 180 because there are no more like terms except for the x terms. Then we'll subtract 60 from both sides to get 5x plus 100 equals 120. And divide by 5 to get x equals 24. This could be our final answer and we could be totally done, yay, but we want to be absolutely sure that our answer is correct. So we're going to evaluate our solution to make sure that 24 is our actual answer for x. We can do that by substituting 24 back into our original equation, 2x plus 3x plus 60 equals 180. So let's do that. We will ask, does my solution actually make these angles add to 180 degrees? Let's see. We have our 2 times 24 plus 3 times 24 plus 60. We're putting in the 24 for each of those x's. And we want to see if that expression equals 180 degrees. You'll notice I have a question mark above the equal sign. That's because I don't yet know if my expression equals 180. We're investigating to see if our expression equals 180, and therefore 24 really was our correct answer. So we'll have 2 times 24 to get 48, plus 3 times 24, which is 72, plus the 60, and we want to again see if that adds up to 180. And yes, when you do 48 plus 72 plus 60, you really do get 180, which is definitely now equal to 180. So we remove the question mark, and this is verified. We have now found balance in our equation. Now that we have the same number on both sides, two 180s, that is proof that 24 really was our answer for x, since it created balance in our equation. And we got this answer totally right. Yay.